Thank you very much. Thanks for coming along to this talk. So as you heard in the intro, I work for Confluent, one of the companies behind the original Apache Kafka project. And we've got Confluent Cloud, which is a managed Kafka platform. And this afternoon, I want to do a bit of a different talk to what I normally do. So it's all about using Kafka. Just show of hands, who's using Kafka today? Quite a lot of you. OK. So this isn't kind of like what is Kafka type talk. This is what you can build with Kafka. This is how you should think about building systems around data, about thinking of events as the primary object when you start modeling your data. So I live here in North Yorkshire in England. It's a very beautiful place. But as part of my job as a developer advocate, I travel around quite a lot. And I kind of do this kind of thing. I do lots of talks and lots of demos with fairly simplistic examples. It's like, here's this cool bit of technology. Let me give you a very simple example of how you can get it to do things. I thought, well, actually, it'd be more interesting to certainly at least prove to myself that all the different pieces that I'm talking about, that you can actually build together into something substantial. So I was on the road one day and I was thinking, what can I actually use to build out this demo? I don't work for a company that's got all this data that I could actually build a real thing around. And I was on the train and I realized that trains are actually a really good source of data. And in the UK and probably elsewhere as well, the train companies share some of their data. There's an open data initiative. And so one of the companies in the UK, Network Rail, have got an API that you can sign up for, and you can get live streams of information about the trains. So this is kind of cool, because it gave me a source of information, a source of data that I can hook up to a real-time stream of events that I can actually start building out into things. One of the things that's really interesting about Kafka and about building systems around Kafka is that it brings together these two worlds of analytics and applications. And traditionally, and very much so still today, you see at conferences, at meetups, whatever, this real divide. People are like, I'm an application developer, I'll go to the application developer talks and so on. I'm an analytics person, I build databases, I've got data warehouses. These are completely separate things. And people think of, well, I build applications, I've got Kafka, I'm going to use it as a message bus. Oh, well, I do analytics, I'm going to use Kafka as like this pipe of getting data from here to there. But Kafka is actually this platform that underpins everything you do with data in your business. It's this event streaming platform that isn't just a pipe, it's not just a bus, it's a platform in its own right. So I want to show you what I built using this data and actually explain why it makes an awful lot of sense to do it this way. Not just because it's a good example of playing around with some technology that's shiny, but because it actually makes a lot of sense to think about data and work with data in this way. So one of the things that I did with the data was to build it out into some real-time dashboards showing the current status, some current analytics on what's happening with the trains. Are they late? Are they on time? What's the distribution of them? You've got kind of the actual trains as they're arriving. You've got the distribution over time. You can start to drill into it and see, like, looking for a particular location, when did the trains arrive and so on. And then dig into it even further. Why do trains get cancelled? What are the different reasons? What's the distribution of those reasons? Dig into it even further. Do they get cancelled by different operators for different reasons? And actually do this analysis on your data. The kind of classical analysis that you would want to do from an operations point of view, with a near real-time view of your data, and a longer-term analytical view of your data, like looking historically what happened with that data. But with the same set of data and the same infrastructure, I also built this, where you've got real-time notifications of events happening on the network. A train just got delayed, a train just got cancelled. I've set a threshold for a particular station, only tell me for that station over this threshold if a train is delayed. So just building a very simple event-driven service, but driven by the same set of data. So this is the idea of bringing together both the applications and analytics and building them around the same platform and the same data. Because that's what it is at the end of the day. It's the same data that drives our business. It's just we decide to artificially segment it into these different technology stacks. But what Kafka can actually do is sit at the heart of what you're building. So I'm going to walk through how the data got in, how I processed it and built these things, and how we used it at the other side. So you've got the data coming in. You've got various different sources. So you've got kind of like the ingress side of things. You've got the transformations bit. And then we've got the using it for the real-time dashboards, using it for more advanced ad hoc analytics, using it for real-time event services. The cool thing about this, though, is that you don't actually have to write any code, because all you actually need to do is write some configuration, a bit of SQL, and some more configuration. So whilst Apache Kafka is kind of like fairly heavily rooted in the Java and Scala ecosystems, and it's got Java and Scala clients and producers and consumers and so on, there's also C, C++, Python, and so on. There's also abstractions on top of that. You've got Kafka Connect, which is just configuration-based. You've got KSQL, which is just SQL. So you don't even have to be a real developer, and I use that in heavy air quotes, to actually build out these kind of pipelines. And I'm not being rude, because I'm not a real developer, because I don't write Java and stuff like that, but I can certainly write the hell out of some JSON. All of this is on GitHub, so it does actually work. It's not just a bit of slideware, so you can go and get the code online. You can sign up for the open API and actually build it yourself and run it yourself. So it's all built around Docker, so it's kind of easy to do. So the first bit is to look at how we actually get the data in. And I realized when I was looking at the title of this that I've talked about Streaming ETL, which instantly alienates at least half the audience. Because they're like, well, I'm an application developer. ETL is something that kind of like funny team over there doing, like with their data warehouses and their slow kind of like old-fashioned things. I'm an application developer, I don't do ETL. But if you think about how a lot of people work with data nowadays, they do actually do ETL. You take data from somewhere, you do something with it, and you put it somewhere else. I've got my application, it's driven by events, I look at those events, and if something happens, I put the data somewhere else. It's ETL, it's extract, transform, load. It's just that ETL in its kind of like traditional sense is rooted in that history of kind of like funky old data warehouses and things like that. It's equally valid over there, but actually the two worlds are completely merging. So this idea of streaming ETL. So we've got data coming in, we've got information about where the trains are on the network. A train arrives at a station, it goes past a signal, another signal, it gets to another station. Those are our kind of easy to comprehend events. It's an event. The train moved. The train got cancelled. And then we've got reference data. We've got information about the schedule that the train was running to, where was it supposed to call at which particular times, and other reference data like the stations at which it called, where are they? What are some of the codes, what are the reasons why trains got cancelled? So real-time event data and a whole bunch of reference data. So this is about trains, but I'm sure you can easily kind of align this back to your particular business domain that you work in. You've got events, you've got stuff happening, and you've got information about that stuff. You've got reference data, you've got dimensional data, and you often want to use these things together. So to get data in and out of Kafka, generally you're going to use Kafka Connect. If it's a system upstream or a system downstream, Kafka Connect gives you this ability to build streaming integration. So whether you've got data sat in a database, in a message queue, in a flat file, in wherever it is, you set up a configuration file, you say, I'd like data from there, and I'd like to stream it into a Kafka topic. It works the other end as well, which we'll talk about later. But it's just configuration files, so it's super easy to use. And Kafka Connect is this scalable framework for doing integration. It's part of Apache Kafka. So if you're using Apache Kafka, you already have Kafka Connect. And it's a pluggable framework. All of the tricky stuff, all of the scalability, the fault tolerance, the managing schemas and offsets, and all that stuff that you have to do when you integrate with other systems, Kafka Connect does for you. You simply find the appropriate plugin for the appropriate technology that you want to work with. And if there isn't one, you can write it. But all you're doing then is writing that particular piece of integration for that technology. Kafka Connect still manages the much broader piece of integration in general for you. Another tool I use is called Kafka Cat. So there's a fair few show of hands of people who are using Kafka. If you're using Kafka and not using Kafka Cat today, definitely go and take a look at it. It's a fantastically useful little tool, both for just kind of as a developer or administrator at the command line, also for building out pipelines, as I'll show you. So the movement data, the information about the trains. I'm not going to go diving into the data model. We'll talk a little bit about data models later, but it's basically a train moved. A train got cancelled. Where is that train on the network? It's just events. And the data comes from ActiveMQ. So the great thing about Kafka Connect, is that you can plug and play your pipelines. So here the events are coming from ActiveMQ, but actually it just ends up on a Kafka topic. So it could be ActiveMQ here, it could be JMS, it could be a database the events are coming from, it could be from anywhere. I'm just saying, oh, I've got events coming in, ActiveMQ connector, and I plug that in. I configure it, I say I'm going to use the ActiveMQ source connector, here's my endpoint, and the event starts streaming into a Kafka topic. So I've now got my message queue, which I'm using whether I like it or not. In this case, it's a third party said, here is your source of data. It could be another team in the organization saying, no, we use ActiveMQ, we prefer that, we've got Rabbit, we've got whatever. It's like, okay, fine. I'm using Kafka for lots of very good reasons. That's fine. I can integrate with your message queue and still use Kafka and all its benefits. So we've got the data coming in into a Kafka topic. Now, the fun thing about building this was that it goes beyond the kind of like hello world examples. That's the hello world example. Here's your endpoint, here's your connector, it works. But of course, as we know as developers, it doesn't always just work. So the data that comes in from ActiveMQ, you've got the envelope around it, and then you've got the payload. So you've got the header to do with the message itself from the source message queue, and then the payload, which is a batch of all individual actual messages. And it's those actual messages that are our events that we want to translate into a single event, each one being a single event on the Kafka topic. So to do that, we need to get the data out from that source message that comes through and explode it out into multiple ones. And for this, I just use Kafka Cat. It's a bit of a hack. If I had to actually productionize this, I might kind of like work out, is there a better, more resilient way? But I've had this running on my home server, and it's pretty damn resilient, so it kind of works. But Kafka Cat consumes from the source. It pipes, which is why Kafka Cat's brilliant. It just integrates with the kind of the pipes theory. So pipe from Kafka Cat as a consumer, run it through JQ. So if you're not familiar with JQ, it's a superb command tool for working with JSON objects. It explodes out the payload and then pipes it into Kafka Cat as a producer to write it back onto a new topic. So first little bit of the kind of devil in the detail done. Data coming in from ActiveMQ, explode it out using Kafka Cat and JQ. So now we've got a Kafka topic with every single event being on its own. Then we've got the reference data. We've got the reference data coming in from lots of different places. You've got data sat on like S3 buckets and flat files and web pages. To get it from S3, Kafka Cat again. So we curl to pull it down, we pipe it through Gunzip, we pipe it into Kafka Cat. Are there more appropriate, more resilient ways? Possibly. But this is a lump of reference data that I need to pull in once. So actually, I'm not going to over-engineer it. I pull down the data once, and we're good to go. I can rerun it if I need to. Done. Other data that I pulled in was some geo data. So I thought it'd be kind of cool to look at where the trains are on the network. We actually overlay that with the information, the geocode information, so we can start plotting it onto a map, because it kind of makes for a cool demo. It looks much nicer. So I found this good OpenCage API. You can give it a name. You can use a REST call to actually pull that information out. And from that, I just built up a JSON file, which you can guess, Kafka Cat, shove it into a Kafka topic. So all of this ingest is about loading the Kafka topics, whether with a continuous stream from ActiveMQ, whether with just kind of like static loads of data. Also had information from a web page, which just like translates the reason codes. So this is all like the actual real data that we deal with day to day. It's sat on a wiki page somewhere. It's sat on like a S3 bucket somewhere. We need to get this data into Kafka, because then we can start joining it all out to these other things. So again, Kafka Cat there to get the data in. So ingest looks like this. Kafka Connect, where there's an appropriate connector for real-time streaming integration from systems upstream. And then Kafka Cat is a very useful way of kind of like stringing together other bits of I guess, ad hoc integration, you call it. The next bit is transform. We've done the extract, we're now doing the transform. So to start transforming the data, we need to understand something about the data model, because at the moment all we've got is a set of separate Kafka topics with data on, which is kind of fun, but it doesn't actually give us anything. It just gives us this raw set of data, which I guess we could open up to other people if they wanted to do their own thing. But I want to build an end-to-end pipeline here. I actually want to enrich the data and transform it and build something from it. So the root entity within this is the movement. A train moved somewhere on the network. It arrived at a station, it departed from a station, it arrived at some signal points. And when it moves, it's got a location. So the movement is the entity coming through from ActiveMQ. Our location is our reference information that we've got. And we've also got something called a schedule. So this is where it gets a little bit funky and down into the weeds, and kind of took more time than it should have to understand the data model, but I did. You're welcome. So the schedule information explains about the train being planned to run. So like next week, the train at 9:16 is going to run from this place to that place and call it these different ones along the way. The schedule gets created, and on the day, it gets activated. So we can then join from a schedule, an activation to an actual movement of a train. So with that data model, you can then start to understand how do I actually link these different events together so that when I get a movement event through saying that train 42 is at location XYZ, I can explode that out into this was the train, it was going from here to there, it should have been here at this time, it was a diesel locomotive, blah, 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 blah. All that useful stuff that as end users, whether of analytics or an application that's pushing that information out, will want to know. So to do the transformation, we've got streams of Kafka topics populated from wherever, and now we need to transform them. So we're going to take this stream of events and somehow process it. And there's different technologies, different tool sets for doing this, but let's kind of abstract this a little bit. Let's imagine that we've just got a stream of events and we want to do something with it. We want to filter that stream of events. So we've got these different widgets arriving and they've got different properties, and one of the properties is color. So we now want to say, of this live stream of events, these live widgets that are arriving, any red widget, we want to copy that onto a new stream. We want to take everything that's there already, because Kafka persists data, remember, it persists it for as long as you like. So take all of the existing data, plus all of the new events as they arrive. If any of them are red, copy it to a new topic, because you've got an application somewhere that needs to know about red widgets when they happen. We can do that using KSQL. We can do it using a bunch of other languages as well if you want to, if that's what you prefer. But KSQL gives you this abstraction on top of Kafka Streams. Kafka Streams is a Java library. It's part of Apache Kafka. It's fantastic. KSQL abstracts on top of it, and it means that you can actually declare what stream processing you want to execute. I would like to create a stream, create a new Kafka topic, as populate the results of the select statement. Select everything from the widget stream where color's red. Do this, match this predicate. It's declarative. It tells us what we want to do, and it goes off and does it. And KSQL is a continuous processing language. It's a continuous query. So that select runs forever, because Kafka is infinite. Kafka is unbounded. These are event streams. We don't know when they will finish. They might pause. The network might glitch or whatever, so there might be a pause in the events arriving, but it is unbounded by definition. So the select runs forever, which means that it's continually populating that target stream. So we've got an inbound stream, an inbound Kafka topic called widgets. We're creating a new Kafka topic called widgets red, continually populated by any events on that source that match the predicate. And it's SQL. So you can run functions, you can do concatenations, you can do joins, you can do all sorts of stuff, but you declare what you want to do. And when you want to run it, you simply pass that SQL statement to the server. There's no boilerplate and so on to wrap around it. So we've got our data coming into Kafka, our event streaming platform. Kafka's persisting our data for as long as we would like. So we might say we're going to keep the location information forever, make it a compacted topic. It's kind of reference data. We'll keep that forever. The events, the movements around the network, maybe we keep for like 6 months or 6 years, whatever. We can configure that. We persist that data in Kafka. Because we persist it, we can reuse it and replay it whenever we want. And then we're taking the data from the topics as it arrives into KSQL, enriching it and writing it back to a new Kafka topic. So that's the general flow. That's the general pattern to follow. Data comes in, you enrich it, you write it back onto Kafka, and then from there you can consume it, whether out to another application or push it down to a target data store. So some of the processing that we did, we took data coming in from ActiveMQ, and this was the next kind of like devil in the detail bit. Not only were the messages kind of with an envelope wrapped around them and batched up, the messages also had multiple different types on the same queue, on the same topic. So you had movement topic, but actually you had different message types. Again, a common way of handling data in systems, but for processing, we actually need to split that out. So if you've got a type as 003, that's a movement. If it's 002, it's a cancellation. We need to route those to different topics because I handle them in different ways. So KSQL can do that. KSQL can say, I'm going to subscribe to this stream of events, and if I match this one, I'm going to write it over there. If I match this one, I'm going to write it over there. And to do that, we simply say create stream, stream name, topic name, as, select everything from there where we match this condition. So you'll notice there we're handling nested structures. So the header is a nested JSON object. You can reference items within that. So we're saying, look at the movements as they arrive. If it's 003, then write it over to this topic. If it's 002, write it to that topic, and so on. You can also do joins. You can say, I've got these movements coming in, and the movement's got a foreign key out to a bit of information that we want to know. So we've got a train arriving at 10:001, location ID 42. Where's 42? I don't know. If only I had somewhere to go and look that up. I have. I've got my location information. That location information came from an S3 bucket. It could equally have come from a database. The point is we've got that information sat on a Kafka topic. So with the data sat on a Kafka topic, we can write a join. Create stream enriched as select XYZ from event stream, left join to location on foreign key equals primary key. So now any event that comes through, we enrich it with information about the location and write it out to a new enriched stream. So the pattern to follow here is the data, you bring the data into Kafka and you do your joins within Kafka. Kafka almost acts as your master definition of the data. You can replicate the contents of a database in real time into a Kafka topic. You could push that out elsewhere if you needed it, but Kafka acts as the kind of like definitive copy if you want. You're not doing lookups out to another system. Lookups out are slow, kind of like bringing a cache in, like invalidates, gets kind of, you have to invalidate it and so on. You bring the data in from other systems using Kafka usually, and then do the joins within Kafka. You can also enrich the data. So if you're used to building out traditional ETL, you'll be used to the idea of kind of concatenating things and defining keys and all that kind of stuff. So here we're saying, well, we've got 3 different fields, and you need those 3 different fields to define the unique key on that entity. So we concatenate them, and then we can actually partition the new messages by that key. You can translate codes. So we saw a moment ago doing a lookup out to another thing. Do a lookup on the location key. If it's this, look it up and join it to there. But another option is simply to say, build a case statement. So on the right-hand side there, we're saying, look at the power type column. So the second column from the right-hand side. If it's E, we want to translate that to electric, because there's only a handful of definitions. They're never ever going to change. We'll just hard code that into the SQL code itself. So a simple case statement. If it's this, then output that. If it's this, then output that. Just standard SQL. But the point is, each of these changes is now being pushed down onto the target Kafka topic. Let's talk about schemas. Schemas are kind of important and kind of scare people or bore people. Both of those things are kind of bad because schemas are really important and they make your life easier in the long run. And they also make a successful Kafka deployment more likely in the long run. Because if you start off with Kafka and just think, oh, I'll just use like JSON, or like I've got a death wish, I'll use CSV, it's like, it'll be fine, I know what the schema is. That ends up with being something that's very kind of ring-fenced because no one else can easily use it. All this idea of kind of like loosely coupling your things becomes tightly coupled together because you still know what the schema is, someone using the data doesn't. They can guess what the schema is, but they don't know. So we need to think about the schema on the data, and all the data coming in is JSON and in some cases CSV. That's a decision made by the third-party systems. We're going to use Avro. We're going to decide that actually a serialization format that cares and is explicitly opinionated about schemas is a good idea, because other people who want to use that data then have access to that schema. So the data comes in, and we define the schema. So this is a case SQL statement. We're saying, here is the schema for this particular data. It comes off this topic, and it's in JSON. We can't do anything about the format that it's in upstream. It's in JSON. We have to declare the schema on the stream. But what we can then do is start to pick out particular fields and overlay the schema on that JSON within it, and then we can reserialize it. So we're declaring the schema as we go, and then we're going to reserialize it into Avro. So what Avro gives us the ability is to store the schema in the schema registry. So we're not passing around files like AVSC files or files on GitHub to define a JSON schema or whatever. We've got a schema registry which stores the schema. So KSQL or Kafka Connect or your own producer, they serialize the data using the schema registry serializer. The schema goes up to the schema registry. The message itself gets serialized into Avro with a little byte on the front that references the schema ID. So you end up with much smaller messages on your Kafka topic, which is also a benefit. So now the data goes on. We've declared the schema once at ingest. And now when anyone wants to use the data, whether it's Kafka Connect as here, whether it's KSQL, whether it's your own consuming application, they simply go to the schema registry and say, what's the schema? And it says, oh, here are all your fields and data types. So it makes it much, much easier to work with. If it's KSQL, you simply say, create stream on this topic, and it goes and gets the schema. You don't have to type out all the fields. If you're using Kafka Connect, it goes and gets the schema. If you're using Kafka Connect to push it to a database, it'll go and build the tables because it knows what the schema is. So schemas matter a lot. So you can use KSQL to re-serialize the data. So when we're creating these derived streams, we can say, create this target stream as the results of that select statement, but we can say with value format equals Avro. Select everything from this source stream. In that case, we're doing a filter, but we don't have to. So you can re-serialize your data using KSQL. You can also do more advanced stuff. You can start to modify the schema, not only changing the field names, so you can use the as syntax. So select this field as that, but you can also flatten it. So you've got a nested structure coming in, all these kind of like nested bits. You can say, well, I'm going to pick out this one, and select it and just flatten it to make it much more easy to work with. Perhaps for a system downstream who says, we need a flat version of this. You say, well, that's fine. I can write a stream processing application which does that. It's a few lines of SQL. It writes it out to a new target topic, and off you go. You can consume it. So in all of this, you end up kind of like daisy chaining these different statements. So you've got your original ingest, you explode it, you split out the different types, you do the joins, the location, and you kind of like end up with this kind of graph of all the different statements. And at the end of it, you're writing back into Kafka these enriched or these kind of like intermediate topics, which you can then consume at the end or along the way. You may find applications which say, I only need kind of this partially enriched data. I actually want more of the raw data than you're filtering out downstream. What I wouldn't do in all of this is try and optimize too early. You're building a platform on Kafka. One of the brilliant things about Kafka is that if you enable people to with the security permissions, other people can use that data. So if you optimize early and say, I'm going to drop every single field except for this one because only that's the only one that I need, well, that kind of makes it more difficult for other people who probably want that data as well, but a more broad selection of the fields. So kind of be sensible in how much you preserve. Don't preserve everything if it's all useless and going to take up too much space. Just kind of like think about it. So we've brought the data in. We've transformed it, in this case using KSQL. Now let's actually build things with the data. So KSQL is writing back into Kafka, and we can now push it down to various different places to satisfy different requirements. Kafka acts as a brilliant layer within your infrastructure. Kafka's not designed for some things. It's not designed for ad hoc analytics. It doesn't pretend to do that. There are other systems out there which do that much, much better. But Kafka acts as this fantastic integration point and enrichment point. You transform the data once, and then you use it in many different places. You want to do ad hoc analytics at scale, that's fine. You use Kafka Connect to push it down to S3 or up to Snowflake or something and do your big crunching there. You want to kind of a near real-time operational dashboard, you push it somewhere like Elasticsearch and stick Kibana on top. You want it in a database because your kind of analysts want it in a database just because. That's fine, Kafka Connect pushes it to there. But it can all consume from the same topic, and because Kafka persists data, it can consume it independently. S3 goes offline, that's fine, the other things aren't impacted. S3 comes back online, it replays from where it got to previously when it was pushing to S3. So again, Kafka Connect gives us this ability. I've got data in a Kafka topic, I want to get it somewhere else. I've got data here, I need to put it into Hadoop. I know, I'll go and write a Spark job. No, please don't. I've got data sat in a database. I know, I'll write a Java program to pull it into Kafka. No. You're reinventing the wheel. You're trying to solve a solved problem, and with all due respect, probably not as well as Kafka Connect does it. That's what it's there for. It does that integration between systems, both upstream and downstream, and Kafka. So you've got data in Kafka, you want to get it to Elasticsearch, to a database, to S3, to wherever. You simply set up a configuration file. Which connector do I want to use? Where's the endpoint? There's the topic, and off we go. So at the beginning, I showed you the ActiveMQ, and I was like, here's the hello world example, but it's not as simple as that. Generally, outbound, it is as simple as that. Here's my JSON, and here's my data. It does work as simple as that. So now we're pushing data, our enriched data from our Kafka topics, out into Elasticsearch and using Kibana on top of that to do kind of like funky visualizations on top of it. We can push data down to a database. There's a JDBC connector. So here we're using Postgres, but any other database will also support JDBC. It can create the target tables. It can do upserts. It can do all sorts of clever stuff like that. Down here at the bottom, we've got something called single message transforms, which enable you to actually do lightweight transformations on the data as it passes through Kafka Connect. So if you want to like drop certain fields, we've got this topic here, but we don't want to push down all of the fields. You can drop those out at egress time. You don't have to create a whole new topic within Kafka. So single message transforms are also a useful part of the toolkit. So with the data in the database, you can say, well, that's great. I can now do my traditional analytics type workloads. I can do my pivots. I can do my aggregate queries. I can say, for each of the operating companies, how many of the trains were on time, how many were late, how many were delayed. And of course, I need it in a database to do that. Right? Well, not necessarily. Because it turns out KSQL also supports aggregates. KSQL can also build stateful aggregations and persist them. So you can actually write a KSQL statement, and that is valid KSQL that runs, that works, which takes an inbound stream of events and computes, as the events arrive, the aggregate status. And from that, you could actually query it if you wanted to. So you don't actually have a database. So if you're pushing your data into a database simply to build that so that your application can query it, you should probably be doing that. Because what's the point of pushing it to a database if you can persist that state within KSQL and Kafka itself? If you're pushing it to a database so that you can run lots of ad hoc type funky things, you should probably do that, because that's what databases are really, really good at. But one of the things about Kafka is understanding, why am I using this other tool? Am I using a database just because that's my gut instinct, like my reaction? Build an application. OK, here's my database. Well, you don't always need a database. Sometimes you do, but not always. Kafka lets you use the most appropriate tool. I'm doing graph analysis. Great. I'll go and spin up Neo4j and push my data into that. You can use the most appropriate tool for the work that you're doing. Push your data into S3. There's the query, or the JSON configuration. It's a bit lengthier, but it works. From S3, you can then do similar type ad hoc workloads. You can say, I'm going to run Glue against it. Glue's really cool. I've not tried it before this. And actually went off and figured out my whole schema, which was super cool. And then from that, similar type analytic queries. But all of these queries that I'm running are based on data that's coming in from the source system, ingested into Kafka, transformed with KSQL, and pushed down to the target system, just using JSON and just using SQL to do so. The alerting bit, I want to show you a little bit about how I built, because it's actually cool building an event-driven application just using configuration. So this is using Telegram. If you're not familiar with it, it's just a messaging app like WhatsApp or whatever. And it's got an API, so you can push stuff to it, and it'll push out notifications. So here, I took the inbound stream of movements, that Kafka topic, and a configuration topic. That configuration topic said, here's this particular station, and here's my threshold, here's my SLA. Do a join between those, so do an inner join. So join between the movements. If you find a match, because it's an inner join, then continue. If not, then don't, because it's an inner join. With a predicate. If the variation, so was the train late by a certain amount, is greater than threshold, then emit it to this new topic. So we've got a new topic populated by all of these threshold breaches in real time. And then we simply hook that up to Telegram. So there's a HTTP sync connector for Kafka Connect, point that at the Telegram REST endpoint, and off you go. I'd love to explain compacted topics, but I will overrun in time. I'll put all the slides online. You can talk to me afterwards and so on if you want to know about it. To run all of this, you can use Control Center. Confluent Control Center is useful for monitoring where consumers have got to. You can look at the throughput and so on. As I said, it's a bit of a hack. So there's bits of cron tab that actually keep it hanging together and running. It does so very effectively. There's a script which shows all of the different connectors that are running, the indexes on Elasticsearch, what was the timestamp of the one most recently ingested. Again, KafkaCat, our friend KafkaCat, can pull off the most recent message, look at the timestamp and show it on the command line, so you can see what was the latest one. So this is what we've built. Data coming in through ActiveMQ, our stream of events, S3 is our source of reference data, plus a couple of other bits. They stream into Kafka using Kafka Connect. KSQL provides us our stream processing, and then Kafka Connect pushes it out to the different systems for real-time analytics, ad hoc analytics, and also kind of event-driven notifications. All of it is built using configuration and SQL. There's no actual code that I had to write, which is quite good because I suck at writing code. If you're interested in trying out Kafka, Confluent Cloud gives you fully managed Kafka. There's a try it free type thing where you can go and spin it up. You've got managed Kafka, you've also got managed KSQL, and Kafka Connect on there as well. If you want to learn more about Kafka, you can get these books for free off our website. I'll tweet the link. You can tweet me up there as well if I forget to. That's the QR code to scan to get it. These are all just free downloads. And they're really, really good reference if you want to learn more about Kafka. I Love Logs gives you a lot of the kind of fundamentals of why is a distributed commit log such a fundamental concept in engineering. There's the code. I'll share the slides if you don't get the link. And that is the end. Thank you very much.
Thank you, Robin. I will start with the most important question from the audience. So the question is, where can we get that Kafka Stream T-shirt?
This is limited edition. My colleague Victor Gamov made it. I think they should probably make some more because people do tend to like it.
Okay. The actual question. So. The most upvoted, what do you do if a record key schema has changed? I mean, it will break co-partitioning of streams being joined because of different schema ID in new records.
Yeah, so if the schema changes, then you're going to have to manage that. In KSQL at the moment, that story is evolving. Within Kafka Streams, the schema registry has options for evolving schemas and compatibility around that. But the thing about schemas, that the reason why people shy away from them is that they find them awkward. I just want to change something and it's saying I can't. But the schema registry acts as a useful gate because you're not just building your own little end-to-end application, your own little tightly coupled thing, which has to integrate with a whole bunch of other tightly coupled things. You're building something around events which other people want to use, and to use them, they need a schema. Almost always. So if you just go changing shit, then it's going to break for them, which is why schema registry gives you this ability to enforce compatibility so that you can only change stuff in a thoughtful way. And if you just want to say, like, screw it, I just want to change it, then you can like start writing to a new topic and tell people like, hey, screw you guys, you can just start reading from here. But we've got a new schema. So the simple answer is there is no quick way to do it unless it's a compatible schema for forward evolution.
Okay. Also, we have a few questions regarding features in KSQL. So I will try to join them. So does it support triggers like in the usual SQL? Does it support window functions? And can I use a processor APIs, example, punctation with KSQL? Okay,
good questions. So does it support triggers? No. Your trigger is your event on a Kafka topic. That's what your trigger is. If you're, I'd be interested to chat afterwards because I probably need to explain better the patterns, the ideas around how you build stuff with Kafka and KSQL, because the triggers in a database sense wouldn't make sense. So apologies if I've not explained it so clearly. Windowing, yes, it supports windowed aggregations. You've got tumbling windows, hopping windows, session windows for building stateful aggregations. And what was the third one? Oh, processor API. So there's bits of Kafka Streams that KSQL doesn't do yet. You can kind of get an idea of what KSQL might do in the future by looking at what Kafka Streams does do. But things like punctuation, I don't believe it does currently. There are some things that you simply say, well, KSQL doesn't do it. I'll have to drop down into Kafka Streams, whether the DSL or kind of like into the processor API. There are some things which you could actually encapsulate within a UDF and expose that in KSQL. So not punctuation, but if you've got like some complex processing that makes sense as a lump of Java and doesn't as a lump of SQL, you can wrap that in a UDF and then expose that within KSQL itself.
Mm-hmm. And another follow-up question. Is it good for running ad hoc tasks? And can you suggest any guidance for how to manage a growing number of KSQL jobs in a project?
Ad hoc tasks, like when you're just prototyping with KSQL, you're doing ad hoc stuff. You kind of like select and create stream and drop and whatever. So it's ad hoc in that sense. It's not, so Kafka's this immutable commit log. Right? It's a sequential read. So if you're kind of like thinking of running an ad hoc query against it, like tell me how many people clicked on this thing who was over age 5 between last year and last Thursday when the sky was purple, that's going to suck because it's going to do a full table scan through every single record. That's why you use Kafka Connect to push the data out somewhere else where it does excel at that kind of thing. Not excel, heaven forbid, but you know what I mean. What was the second question?
The second question was about any guidance you can share with us.
If you've got lots
how
of
to
KSQL.
manage growing number of jobs.
Yes. So one of the important things about KSQL is that you have to think of it in terms of applications, not database clusters. And this is kind of an important point. So last week was Kafka Summit in San Francisco. I did a talk all about KSQL with a bunch of live coding and a slide on there, which I'm not going to try and find now, which explains how you should think of it. So go and look at the recordings when they're out. The slides are online. But the point is, if you're writing an application, like I had there, that was an application. It enriched movement data. It looked for cancellations, possibly the delay, the trigger thing, looking for like if a train was delayed by a certain thing. That would be its own separate application. That would be its own KSQL server. It's applications that we're building. It's not the same idea of we've got a data warehouse on Oracle, and here is our analytics team, and they do ETL and they do ad hoc queries. There is their great big Exadata on which all of their stuff will run, and we will have an absolute nightmare trying to segregate the workloads. KSQL is about, I've got a stream process application that does this, that does that, that does this, and you can deploy multiple KSQL servers within a cluster, but I've got multiple clusters that I size based on the workload they're doing, and that then isolate the workloads by default. And then probably I've got like a separate KSQL cluster just for kind of mucking around on. You can even separate your Kafka clusters and use something like Replicator to say, well, here is my main Kafka cluster where all the stuff's happening. I'm going to do a one-way replication from this cluster out to this one and point my just kind of like KSQL mucking around stuff on that. So I can still prototype and do whatever, but I'm not prototyping against my live Kafka cluster. So that's the way to think of that.
Okay, I think
I have one question for you guys. Can I do a speaker selfie with you, which is kind of lame, and I don't know if it'll actually work with these lights, but we're going to give it a try. It's super bright. Thank you. Sorry, I cut you off.
No, I just wanted to ask the last question, which was quite popular. Do you know any external tools how you can visualize data in Kafka? How you can make data visible using the graphical interface? So
Confluent Control Center has that. If you're talking about kind of like, I want to look at my topics and what messages are there, what topics do I have, what's the throughput rate and stuff like that. If you're talking about, I want to do visualization on that data and kind of break it down by actual numbers and stuff like that, then I'll probably push it out. And I always reach for Elasticsearch, but there's other stuff as well.
Okay. Thank you very much for your talk.
Thank you.